Hey.
Good to see you. Welcome back.
Yeah, thank you. I'm glad to be back.
A whirlwind month this past month. We've got all kinds of things happening up in the skies.
Absolutely, yeah. It's been very dense lately, for
So
sure.
the meteor showers, is it like clockwork? It happens every year at the same time?
Yeah, so it'll actually be back. And we're hoping that as long as the weather isn't too miserably cold, in December, the Geminids will actually come around. And so we'll get to do it again this year, which will be really cool. And then, of course, in next August, we'll get to do the Perseids again. Yeah, about the same time every year. So.
What's the difference between northern lights and meteor showers?
Oh, yeah, that's a good question. So they're caused by different physical phenomenon, right? So a meteor shower is the result of essentially debris that's in the orbit of Earth, and then we run through it. So we're actually running into the rocks, they're not running into us. And then as those rocks come through the atmosphere, I think like pebbles, like gravel, right? They basically vaporize and they get really bright, and we get those nice, really cool streaks coming across the sky. The northern lights are a different phenomenon. So the sun is constantly ejecting particles. We call it the solar wind, right? And so you have these charged particles that are coming from the sun, and they hit Earth's magnetic field. And those charged particles, they get attracted to the poles, right? Which is why the northern lights or the southern lights are near the poles, because the particles are actually accelerating towards, and as they do that, they turn the air around them into plasma, and so you get that really cool light that we see.
All right, well, I hope everyone got that. But just in case you didn't, you're having a special event, Exploring Modern Astronomy, this Wednesday. What's it all about?
Yeah, so it's going to be a really cool event. So Dr. Meyer, who is the chair of astronomy at University of Michigan, has agreed to come down and share some information about the research that he does, which is really cool because he does a lot of research involving the James Webb Space Telescope. But he doesn't just do research involving it. I was looking up his track record today for funsies, and he has quite the track record. He's done a lot of work on the instrumentation as well and how to implement them, and then also methods for actually reading the instrumentation on top of doing research with the data itself. So it's going to be a really cool talk.
Yeah, I would imagine if you're chair of a department at the University of Michigan, you're something else.
Yeah, you know a thing or two, right?
Yeah.
For sure.
Do you know Professor Michael Meyer?
So I've gotten to meet Dr. Meyer once. So he came down to the observatory, which is really cool. It's not every day that you have local professors, let alone chairs from other observatories, wanting to come out to local schools like Jackson College and taking an interest in what we're doing. And so he wanted to come see the AO, and so we invited him out. We showed off the AO to him. We were talking about collaboration we want to do, because one of the things that we're really working on at JC is working on collaborations with larger schools to send students to. So right now at JC, we don't have a full physics program, right? We have a really awesome first year calendar where you can take your introductory physics courses, your introductory to astronomy, and then of course we have the AO itself, which is an awesome bit of instrumentation, and there's not that quality of instrumentation anywhere near us, U of M included, right? And so having students have that ability to get that hands-on experience is really phenomenal. The issue is that there's not much that we can do capacity-wise from there. And so having pipelines where we can set students down, get them that really amazing base and that experience with that equipment, and then sending them on, right, so that they can finish out those degrees in physics or astronomy is really important. And so U of M is one of those outlets that we're looking to do that with.
Oh, that's pretty cool. Yeah. So we have something technology-wise that even the University of Michigan does not have?
Yeah, we have quite the telescope. So a lot of times with universities, observatories, what you'll find is you put it in an observatory and you usually keep that observatory up and running indefinitely, right? And it's really hard to find the funding after that to just build a new observatory unless you're in a really good spot to do research, because finding a grant to build a new telescope and justify why is really difficult if you already have an educational instrument on site. And so for us, because we just built the AO in 2023, we have this really nice new telescope that is just unlike anything else around us. So
wow, yes, multi-million-dollar telescope on the campus of Jackson College, courtesy of the federal government.
Yes.
Thank you, federal government. But it's
Very
provided a career pathway. Now there are students that can get started at JC.
Absolutely.
And you want to get them fed over to U of M.
Yeah, absolutely. I mean, space and astronomy has been a large part of Jackson's history. I mean, we have some awesome astronauts that have left from here, right? James McDivitt, which the hall is actually named after on campus, right, included in that. And you know, there's just a lot of cool things that have happened in Michigan in this area for astronomy, and kind of being able to keep that alive is really cool. I think it's an important part of our community, and I think it's something that should persist. So
Yeah, well, I think that's great. The Jets hangar actually previously was the space center.
yeah.
Yeah. All right. So you have Dr. Meyer coming in, and you want to get some students coming out for this, right?
Absolutely.
High school students.
High school students would be phenomenal. If you have an interest in astronomy, this is a great time to come explore that. Dr. Meyer is doing research with James Webb Space Telescope, so this is really like active, modern edge research, right? And being able to ask those questions to someone who is so familiar, so just in tune with the instrument, is a fantastic opportunity, right? So if you have an interest in the field, and you know, you're still in high school or early college, or just college in general, or you're thinking about returning to school, and you want to express that interest and see if it's something you really want to follow through on, this is a great opportunity to kind of express that. And then even if, you know, you're not really interested in a career, this is a really awesome opportunity to ask someone who is so in tune with the instrument questions that you're not going to get the chance to ask someone else, right? It's not every day you get to ask someone who works with the data on a regular basis like that, or is so familiar with the instrumentation, questions about the instrumentation. So
Well, that's awesome. Yes. And like, he's an astrophysicist, right?
absolutely, yes.
Yeah. So who even knows what that means?
Means something, you know.
Well, I think we're all, I mean, it's all fascinating, and it seems like there isn't a week that goes by that we don't hear about something, you know, either one of the telescopes has discovered, or we're, you know, seeing we're not alone, maybe. There's, it's pretty fascinating.
It is, and it's a good time to be a fan of space. I mean, you have James Webb that just came out, and that's, I mean, basically Hubble 2.0, right? Like, and then you have the Artemis missions, which is basically the space race 2.0. And if you're not familiar with Artemis missions, that is the current NASA missions to go back to the moon, right? And once we go back in that series of missions, we're actually going to set up a radio telescope on the far side of the moon. Like, there's a lot of cool things happening in space, and we're getting a lot of capacity to learn and grab observations for things that we haven't been able to before.
So you were born after the moon landings.
Right.
So for you, I mean, I understand, I get it, we watched it, you know, it's like we saw it was going to happen, and we couldn't believe it. But to be post moon landings and have your interest, it's got to be, is it mind numbing that we actually sent people and put them on the moon?
I mean, yeah, it's amazing, right? Especially given the equipment at the time. I mean, like, now it's, I'm not going to say trivial, but it's a lot easier than it was then, right? The fact that we managed to do it then at all is phenomenal. So,
with pencils and slide rules.
Yeah, exactly. Yeah, live calculations with someone in a room, you know, in a control room telling you what to punch in. That's amazing. So microcontrollers where they were running everything off a line of code that's literally, you know, 120 characters long, you know, because that's all the space they have. It's amazing. It's absolutely amazing.
It is. All right. Well, I bet we'll get there again, and hopefully soon.
Yeah.
Now you have what beautiful weather this week. It looks like we're going to have some clear
I'm hopeful.
nights.
Yeah, very hopeful. And assuming that the weather is good, we are going to do observing at the AO after the talk. So it'll be a really cool like night out. You can go out, ask a bunch of questions, learn a lot of really cool stuff about James Webb, and then see a bunch of cool stuff at the AO afterwards, right? So.
And we've been doing this all summer, and you hope to continue on a weekly basis, the observatory part?
Yeah, so for public observing itself, we do that every Wednesday, Saturday night from 9 to 11 p.m., as long as the weather's good. And if you go to the website for Jackson College and just type in observatory, the observatory's webpage will pull up. And the first thing on the webpage is whether or not we're going to be open on the next day. Normally what I say is try to check it the morning of. So like if you want to come out Wednesday, check it the morning of Wednesday, or you want to come out Saturday, check it the morning of Saturday. Because sometimes if the weather's a little iffy, we try to give it as long as we possibly can to call it. That way we can hopefully like see the skies clear up and then still come out. So check it in the morning is the best way to do it.
And you do something pretty cool. You get rid of all the light pollution on the campus. when you do that?
Yeah, so we're very lucky. We get to call security and say, hey, we'd like to turn half the lights on campus off. And they just do it for us, which is really, really nice. Very nice of them because it puts extra work on their plate. And yeah, it's awesome. So once the lights are out on campus, a normal scale, we call it the Bortle scale for light pollution, goes from about 1 to 9. 9 would be like downtown Detroit. The only thing you could possibly see is the moon at night. 1 being like super dark, very clearly see the Milky Way in the sky without any sort of aids. We're probably somewhere at like a high 4, low 5, which is pretty good. It's definitely not the greatest observing on the world, right, on the planet, but to be in the middle of town, a 20-minute drive from Jackson, right, and to come out and have access to an instrumentation like that, they're really good skies.
And is this what you can see from your telescope?
Yeah, so this is an interesting image. So this is the image we took of the lunar eclipse back in March. And through the telescope, actually, this image is much, much wider than what the eyepiece looks like in the telescope. So from the focal length of the telescope and the camera, the FOV is about a 16th of this image. So the image you're currently looking at is multiple images actually stitched together of the moon. And so it's a little bit wider than it would normally be. But yeah, you can definitely see the moon in good detail. The color is real, so during a lunar eclipse you would see this color through the telescope for sure.
Awesome. Yeah, I think people might have noticed a really full moon this past weekend.
Yeah.
Yeah.
And the full moon is something awesome in and of itself. One of my favorite objects still to this day to observe is the moon. There's just so much detail and just so much you can look for. It's amazing. So.
And then this picture, it's what?
Yeah, so this is M13, or the Great Hercules Cluster. So this is a globular cluster, so it's an older group of stars. So we're looking right now at about a couple 100,000 stars, give or take. And they're all close to each other, so they're all gravitationally bound. They're all orbiting the same center. They would have formed together. We usually find these in older parts of the galaxy, in older parts of the Milky Way. And through the eyepiece, it does look like that. There's a little less color because you're getting less light exposure in your eye. Your eye takes about a 60th of a second. What you're looking at is like a 5-second exposure stacks of like 60 or so images. So a lot more light in there, so a little bit more color than you would see through the telescope, but you do get to see that glittery kind of structure, which is really cool. They're one of my favorite objects to show off at the AO.
Fascinating. Learn more about modern astronomy on Wednesday night at 6 p.m. Visit gccmi.edu and get signed up. It's free. Everyone's welcome, and it's going to be a big room, so they hope to have a nice sized crowd. Thanks, Travis.
Of course. Thank you.
Travis Marlowe, Astronomical Observatory Coordinator at Jackson College. Well, we've